We are from Group 12 want to present about design and fabrication of a small-scale automated assembly line which is road bike frame. This is our group member. Today, we would like to present our group project titled Design and Fabrication of a Small-Scale Automated Assembly Line. Let's begin with the introduction to give an overview of the project. Automation in assembly lines helps improve efficiency, reduce errors, and enhance safety in modern production. Since the Fourth Industrial Revolution, the use of automation technology has become standard practice in the global manufacturing industry. This project is a continuation of the previous assignment that focused on material selection for the bicycle frame. The main objective of this project is to design a small-scale automated assembly line capable of carrying out the assembly and packaging of the frame components with minimal human intervention. The assembly line will involve processes such as raw material cutting, tube forming, welding, surface treatment, quality inspection, and packaging. The layout must be logical, efficient, and suitable for the selected material properties. Aluminum alloy 6061T6 was chosen for being lightweight, corrosion-resistant, easy to weld, and suitable for automation. This project integrates knowledge of material selection, automation requirements, and the design of a modern, efficient production system. The chosen component for this project is the road bike frame, a critical structure that connects all major parts and supports dynamic loads during cycling. Its design affects performance, aerodynamics, and energy transfer from the pedals to the rear wheel, while requiring resistance to fatigue, corrosion, and impact due to its central role. It is well suited as the focus of this automation project. Aluminum alloy 6061T6 was selected for its wide availability, cost-effectiveness, and ease of processing compared to materials like carbon fiber or steel. It is lightweight, recyclable, and ideal for automated and sustainable large-scale production. This makes it technically and economically suitable for modern manufacturing systems. In this part of the presentation, we will go through the three main stages in the manufacturing process of a road bike. First, the main operations second, the secondary or finishing operations. And lastly, the assembly and packaging operations. The first stage focuses on shaping the core structure of the bike frame. We start with raw materials like aluminum alloy, steel alloy, or carbon fiber composites. These materials are cut and shaped using CNC machining to achieve accurate dimensions. Next, shaping methods such as forming and bending are used to mold the tubes into the bike frame design. For metal frames, TIG welding is used to connect the parts. However, for carbon fiber frames, processes like molding, lamination, and curing are used instead of welding. After the main structure is completed, we move to the finishing operations. This includes surface treatments like anodizing, powder coating, or painting to improve appearance and prevent corrosion. Aluminum frames often go through heat treatment, for example using 6061T6 alloy, to increase strength and mechanical performance. Other finishing steps like polishing and deburring help create smooth surfaces and remove sharp edges. Finally, quality assurance tests are done to ensure the frame meets safety standards, design specifications, and looks visually appealing. In the final stage, the frame is assembled with essential bike parts such as the fork, handlebars, pedals, drivetrain, and seat post. For carbon frames, adhesive bonding is used to attach non-carbon parts securely. Labeling and branding are applied, and then the bikes are carefully packaged using foam, padding, and cardboard boxes to protect them during transport. This process ensures that every road bike is strong, safe to use, and visually ready for the market. Conceptual layout design. Assembly line layout. The assembly line layout starts from the material storage area and flows linearly through cutting, forming, turning, secondary machining, finishing and inspection, and also assembly. Raw material storage station, forming station, cutting station, turning station, secondary machining station, finishing and inspection station, assembly station, explanation machine and workstation placement. Raw material storage station. Placed at the start to keep main materials like aluminum alloy, CFRP, and steel alloy for smooth and easy access to the next process. Forming station. Placed after raw material storage to shape aluminum and steel alloys into road bike's tube. It uses beading, roll forming, and hydroforming to ensure reducing waste before cutting. Cutting station. Aluminum and steel use milling and drilling. CFRP use water, jet, or laser to avoid heat damage. Diamond tools may be used to avoid sharp corners and high clamping pressure. Turning station is used to machine round parts like the head tube and bottom bracket using lathe machines. Blanks should be near net shape to save the time. Thin parts need extra support to maintain accurate and finish. Secondary machining station. Performs additional processes like drilling for parts such as gears, pedals, and mounts. Located after turning to ensure all parts are complete before final inspection. Finishing and inspection station. This station handles surface finishing like grinding and sanding, followed by dimensional and visual checks to ensure accuracy and quality. Assembly station is where the frame, fork, and dropouts are joined to complete the bike. Welding is used for aluminum and steel, while CFRP uses epoxy bonding. It is placed at the end to ensure only finished parts. For conclusion, this project designs a production line for a road bike frame. The selected material is aluminum 6061T6 because it's lightweight, strong, and corrosion resistant. The production process includes cutting, forming, turning, machining, finishing, and assembly. Techniques like welding and epoxy bonding are used depending on the material. Quality inspection is carried out to ensure the bike frame is strong, safe, and ready for the market. Thank you for watching.